Okay, here we are. Hi, welcome back. After the last session where we played around in Sketch a bit, I want to go back to writing some code again, and I want to play around with TypeScript and Jest today. I want to do some test-driven development in TypeScript, where I want to bundle a few of the helper functions that I use or that I shared on Twitter as part of my Fire tips, and I want to bundle them into a library that I can potentially then include in all of my other projects. Whether that actually ever gets used or not is besides the point, because what we want to do now is see how can we do test-driven development at all, and how does TypeScript help us with implementing a few functions. I have again, you're gonna hate my setup probably. I have my editor on the left. In the top right we have the tests running. Then we're also gonna run the TSC, the TypeScript compiler, to see it complain about all the types. For a few things, if there's error messages we can't read well from there, we're gonna jump into VS Code in a bit. Don't really have a plan for what I want to include. I have a bunch of functions that I could add here, and we're gonna take them one by one. Test-driven development basically means that we write automated tests, unit tests in this case, and we write the test first. If we're test-driven, then the test will define what it is that we want to implement, and we will first write a test that is going to fail because we don't have the function that it tests yet. And that test will give us a red result on the terminal. Right now in the top right, I have an example test that is green. We're gonna break that. We're gonna make that fail and be red. Then we are going to implement the function so the test is happy, and we're gonna take it usually one test at a time. And then if the test passes, and we know we get this kind of, if we put this kind of input in, we get the expected output, then we can make adjustments to the code. We call that cycle Red-green-refactor. So we have a red failing test first, then we make sure the test passes, and then we can refactor the code to make sure it's a bit neater and nicer. I'm gonna start with one function here, and I don't have this complete of an example for all of them. Just want to show you how we are going to approach test-driven development. So I have in my head a function that I'm going to call pick. And I want to have a function that I can give an object to, and I can also give it a list of properties that that object has, and I want then to only get those back from it. So if we have this one over here, if we have an object that consists of an email address, a password, and a username, and I want to pass that along my code somewhere. I have a backend endpoint, and I want to pass information to show on a component in React, for example. Then I don't want to pass all the information and expose all that information to the browser. I want to keep the password hidden. So I would give my function this object, and I would give it the two properties that I want to have. I want to pick out of that object, right? And then my output would be what I put in, but only the properties that I gave it. So I don't, because I told it I only want the username and the email, I'm not seeing the password here. Is kind of what we want. And the way we do that, I use TypeScript here for one, and I write the unit tests in Jest. Doesn't matter if you use Jest or some other kind of test runner, if you use Ava, it's always the same approach. We tell it, if we give this function this kind of input, we expect this output from it. So I'm now gonna turn this into a test where I pass it this exact object and these properties, and I have exactly what I have on the right. This is then the output that I want. We have a describe block that describes the entire function, so this will describe the function pick, and I have a test just so I have a test there, because Jest will complain if I have a file that doesn't have any tests. It will tell me, no, not this one, that one. Your test suite must contain at least one test. Okay, so we know the setup works at least, and I now can give it. It has the function test. It removes. It only returns the requested properties. Could call it test. Could call it it. Also, it is an alias for test, and it reads a bit nicer. It only returns the requested properties. That is something that we want to make sure happens. We have an arrow function in here, and we always start with what we expect to happen. So what do we want? Const, let's say the result will be, we call the pick function, and we pass this object to it that consists of email, Clark. Let's actually see. It's too bad that I put this in this form here. I guess that is a markdown form. That wasn't the most clever. A markdown table, that wasn't the most clever idea, but this is, yeah, this works. Remove you. So if we call the pick function with this object and we pass it the username and email, which is two properties that exist in here, we get something back, right? We get a return, and then we expect. So first we say this is like the result that we received. We expect the result to, we're going to start with 2b, and I expect this to be exactly what I pass in here minus the password. So my test in the top right runs. That might be a bit too small. I'm gonna, now that we've turned this into a test, I'm gonna remove that so it doesn't take up more space than it needs. Cool. So the test fails. Still too much. And it fails. It tells me what test failed. So in the pick test suite, where I say describe pick, it only, in the test that says only returns the requested properties, which is this test right here. Reference error pick is not defined. So of course I'm not, I think I could define the function and the test that tests that function in the same file. I'm not doing that here. I'm separating the implementation and the test. So I have to import the pick function from somewhere. So I'm going to import pick from, it's in the same directory. So if we look at the file structure here, I have my pick.test.ts TypeScript file as well, and the pick.ts on the same level. So I can import pick from pick if I export something there. We're going to look at the export in a bit when we get to the implementation. And now something happens. That it still shows me that this one test failed. It's the same test, but the error message is different. So it expected received to be expected. And where it shows me that we expected. So this is what we wanted it to be. Email kent@dailyplanet.com, username Clark Kent, but we received undefined, which means if we transfer it back to the test, the result that we got is undefined, but we really wanted it to be this object here. And that is the first step of our red-green refactor. We have a test that is red. Now we can make sure that the test passes and that the test is green. I'm going to open so the top panel will be the pick TS, that is the function. We export default function. We export the pick function from here. It receives an object and it receives properties, but it doesn't return anything. So of course it receives undefined. If I just return hello here, we see our test still fails, but we now, instead of this object, received hello. Now we want to make sure that step by step we make sure the tests pass. And we try to do as little as possible, because we tend to over-engineer these sometimes. We tend to put a lot of code into the implementation that is not necessary to get to the result that we want. So the unit test describes for us what it is that we want the function to do. And if we have that blueprint first, we can write the code that does exactly that and nothing else. What is the smallest, what is the most minimal step I can take to make this test pass now? And you could think that I need to get the object, get the keys in the object, and then I need to reduce or iterate over them and only take the ones that appear in the properties. But honestly, if we do TDD, it's a silly step. But the shortest thing I can do to make sure that this is the result that we get is I can copy it, and instead of the string hello, I'm going to return this object. Now, the error message changed because the to be is incorrect when we compare objects. It's fine when we compare numbers, when we compare strings, when we compare booleans, when we compare the primitive values. And here it already tells us if it should pass with deep equality, replace to be with to strict equal. No, that's not the one that we want. It tells us that the result serializes to the same thing, but it's not the same thing, because to be means is it the exact same object. And while the object looks the same, it's a different object that has the same properties. It's like I have one red car and another red car of the same make and model. They look the same, but they are, I want them to be different. I don't think that comparison made sense, really. What we do here is instead of the to be, we say to equal. I don't need this to be the exact same car. I want it to be a very similar car. I don't need it to be one and the same car, but I want it to be the same type, make and model and color and everything of the car. And when we do to equal, well, the test just passed. That's good. The implementation, of course, is silly because that function will always return this, which doesn't help us much. Now we're going to see that this no longer works when we write a second test. So let's add a test that says, so what do we do now? It only returns the requested properties, and I want to make sure that if someone requests something that doesn't exist in the object, it's not included. So it does not include if I requested, so I give it an object with email, password, username. What if I request the address or the first name? Let's say first name. What do I get back? Do I get the first name? Would that be empty? I would say it shouldn't appear at all. So does not include requested properties that don't exist. Requested properties that do not exist on the object. So if we say, let's do first name is Peter and last name is Parker, and then we request give me first name and give me alter ego. Then what do we want the function to do? Do we want the function to throw an error? Do we want it to just silently swallow it? And that's the point where we are test driven. We now look at how do we want to use the function, what do we expect the function to do. Instead of doing just random things in the implementation, we now define this is what we want it to do if that happens. And we could go either way, but I am going to say that I want it here to be just first name Peter and not complain about it not having an alter ego. If that doesn't exist, it shouldn't exist in the result. I now, looking at my tests, I have one failed test, one passed test of 2 total. That's a good hit rate of 50%. But it shows me I expected one thing and received another. So I wanted the object with the first name Peter, but I did not get that. So the minus, I think the colors are reversed here, depending on what direction you look at it from. I did not get the first name, so the first name is missing, but I did get email and username because we hard-coded that earlier in the implementation. It doesn't make sense, of course. So now we have to think about actually implementing the function. And we could have done that immediately. I just want to show you it's fine to just make the function do what it says in the test if we strictly do test-driven development. Whether that's a reasonable idea, I leave up to interpretation for you. Not always. In this case, probably not. So how can we now do what we want? I could cheat because I have the implementation right over here somewhere, but we are going to go with what do we have? we get an object that has keys. And to get the keys from the object, so we want the keys is object.keys of the obj. We could even say object. Why these? Can we? I'm gonna say obj. And then we get the keys. And then we want to return an let's do just any implementation, right? So let's say const result is an object, and then for const property in properties, so we are going to iterate over the array that is properties. If wait, do we? No, we don't even need to do that. So result property. So we want to set the property on this result object that we just created. We want to set that to whatever is in the obj under the same name. Property, and then we want to return the result. And I'm going to save it. I don't know if that works at all. That could be a bad, terrible idea, but the test is going to tell me. And I got something very weird back. What did I get? Instead of first name Peter, I got 0 undefined and 1 undefined. So something here is clearly very wrong. So let's do a different implementation. We are going to properties dot for each. We're going to do a for each loop over these. And for each property that we have, we are going to do this. So by replacing the for of with a properties.forEach, the tests pass. If that is the best implementation or not, I don't know, and we don't really care about at this stage because we just passed the second step of the red-green-refactor. We had a red test, now we have a green test, so we know the implementation that we have that works, and we could leave that forever, and we could continue on with our day. Or we could now go to the refactor step and see if there is a more elegant, a more performant, a more attractive way to do the same. And I know that there is. Neat, by the way, that we didn't have to do anything about this alter ego situation. Even though in properties here we have something called alter ego, even though we set something on the object, it will be set to undefined. So let's think about what it does step by step. We have obj is the object consisting of first name and last name, and properties is first name and alter ego. We first build an empty object, and then for each of the properties in first name and alter ego, we first have first name, then we have the alter ego. We set a new value on the result. So we set first name on the result to whatever is in the object that we passed in. And we do that with the bracket notation, which gives us this object and the first name of this object, which is Peter, which shows up here then. And then in the for each goes to the next element in the properties list, which is alter ego. It sets on the result object the alter ego, and it sets it to whatever this input object has under alter ego. It doesn't exist there, so the value is undefined, and that comparison that doesn't show up. Let's see if we can console log, if we can log that out. And we see, okay, let's not put this in the angle, in the curly brackets. If we log the result here, we get first name Peter and alter ego undefined. This comparison with to equal doesn't care about values that are undefined, it ignores them. Alter ego is set on there, it doesn't have a value. So that's not ideal. I'm not a big fan of that being there. The test still passes, and we can see if we can get that out of there in a bit. First I want to try a different implementation, because in the refactor step I now can go properties and we can reduce over the properties. And we can say we don't, yeah, we can put the result right here. No, we are going to call this the accumulator, which is what it's often called in the reduce function. And we are going to, where it says result here, go accumulator. If you have questions about that, ping me in the chat. Otherwise, I will keep going and initialize it. So instead of first initializing the object, we are putting the initialization of this object down here, and we can merge these lines. So instead of having the initialization of the variable and then returning it down here with the reduce, we can do it all in one go. Let's see if I broke something, because if I now broke something, everything is going to fail. Cool, and what did it fail with? Both tests failed, cannot set properties of undefined, setting email. What do you mean of undefined? Oh, okay. My reduce has to return an object after each iteration, so accumulator, that's not the easiest word to say. Cool, so what we saw now is I took my code, I changed something, and I didn't even have to go into a browser, I didn't have to call the function manually. I know the same tests that passed before my change still pass, so I did not break anything. What I still have is the alter ego in here, set to undefined. Now let's see if we can write a test for that. Can we expect something to not be undefined? Can I test for that? So expect result dot alter ego to be undefined. So we can test the positive case. Let's see, because to equal and to be, those are just two of the matches that we have. Let's see what else Jest has for us that could now cover that case. On jest.js.io, we have in the API a list of matchers. Test only? No, where are the matchers? We see we have the to be, to equal, those ones we met already. Truthiness, we can check if something is null, if something is undefined, if something is defined. So we can't check if alter ego is defined because it isn't defined. I wanted to not be there in the first place. Null, no numbers, it's not a number, it's not a string, it's not an array, it's not an exception. And more. Okay, for a complete list, check here. And I would expect something like to have key. So let's say the key or property. You have something with key, to have property. Cool, I expect you to have a property. And let's see if that can cover undefined as well. They pass in a house for sale. And then they check, does it have a property? Okay, so it can check both, does it exist? So does it have a bath? And I'm not sure if it goes for the true here. We can also check for a specific value. So they expect the house to have the property bedrooms of 4. Expect house not to have property pool. So that looks like what we want. I want to check that this doesn't have the property yes. So I can expect my result, and the not qualifier is like a separate element in here. .not to have property. For my test to cover that case, I wanted to have expect the result. Not to have property, I wanted to not have the property alter ego. Just because that is a bit cleaner. It wouldn't hurt, but it's better. It would be better if it wasn't there. I have one fail test, one pass test, so I could have. There is an approach that says there's only one expect per test. where we have one it or one test, and inside of there's only ever a single expect. As they do in the example here, if they are all closely connected, I'm fine with that, because to test both of them, to test that the result is equal to what we have here, and it doesn't have the property alter ego, I would duplicate the code. I would write the exact same test twice, or I would write a very similar test for the same setup. So here I'm fine saying that I have two expects in the same test. Now, how do we make sure that this doesn't happen? We want to make sure that if we have a property in our properties list, so first name or alter ego, we only want to set something on this return object if it exists on the original object that we pass in. And there is has key, is that a thing now? MDN object has own property or has property? I think has property is new, right? Object has own. Is an experimental technology? Nope. Is intended as a replacement? Then we will look at has own property. So if this object has the property object and it's on the class, yeah. Object has, is it? No, it's not. So if obj has own property, if this property exists on the object in the first place, then we add it to the result. In either case, we return the result. Let's look at the test that has own property. I forgot the Y. Has own property. Sorry about that. Wait for the tests to run. And cool, this implementation passes, and it doesn't have, now we adjusted the test, and it still gives me the same result, and it doesn't have this problem with the undefined element, undefined property being in there. We could have done this any other way as well. There's nothing that says this is the only way we can write this function, but it is a way. And as long as the test is happy, then we know that we did a decent enough job. Now, that means that the tests define what we implement. If it's not in the tests, it's not in the code. Like I haven't added a single line of code to the implementation that does something I haven't written a test for. So I now have, I should have a 100% test coverage, because everything I wrote here is necessary, is required for the tests to pass. There could be blind spots now. There could be something I'm not considering here. There could be situations that this doesn't cover, that I just don't, if I don't have a test for it, I don't have an implementation for it. Something could still be going wrong that I'm not aware of. So we have to, if we start out this way with test-driven development, we can either take it one test at a time and did what we did here, or we could say I have a list of 20, 30, 100 tests that I want this function to cover and to match. We are not doing that now, but as an exercise, we could have repeated the same call with other input. We could have tried, what if I have like camel case properties in here? What if I have nested objects in here? I'm intentionally not covering that at this stage. I'm just saying this is like my function in my project is only ever going to receive input that looks like this and properties that look like that. There is one more case though that I think we can write a test for. So what if we don't pass any properties? We now have checked for what if we pass a subset of properties, what if we pass properties, some of which don't exist, what if we don't pass any properties. I think in this case, because we see it doesn't have an alter ego, it returns an empty object if no properties are requested or are passed in. Doesn't really make a difference for the test what we write here. So if we can write the function call in this expect as well. We don't have to put that in the result variable first. Expect pick to equal, and we want this to equal an empty object. So what do we pass in? Name, what's it? Steven. Strange. Dr. Strange. And if we pass in an empty array of properties, I want it to return an empty object. My code still passes. There is something, and that's where we get to the TypeScript part now. What if we don't pass an empty array? What if we pass nothing in there? So we could now cover this with a test as well. It returns an empty object. Wait. To be fair here, if an empty array of properties is passed, yeah, sure. If we pass an empty array, I want an empty object, returns an empty object if no array of properties is passed. And I could now cover that as well. Expect, and we're gonna just copy it. And I could cover this not receiving anything or this receiving undefined. Let's be explicit and be undefined because that's what it would be. And the test would fail because we are now trying to reduce over in our implementation. We call properties.reduce, and we can't call reduce on something that is undefined. We can call it on an empty array. That is absolutely okay. We don't have anything on here. That's not covered. If we pass null, it's the same property. It's the same type error. Cannot read properties of undefined. What if we pass in null? The same would happen. What if we exact same error message? What if we pass in a number, 17? So what if someone uses the function in a way that we don't expect? Properties.reduce is not a function. It's no longer is undefined, but it's not a function because we're trying to call 17.reduce. That doesn't exist. And we could write tests for all of these situations, which is tedious. We would have to cover someone misusing the function or intentionally or unintentionally passing something to the function that we didn't expect them to pass in. Which is can take a pretty long time and has very little result in the end. Instead, I have another panel here. Let's run a TSC. Let's run a TypeScript compiler on my code and see what TypeScript has to say. Waiting. So it tells me the parameter obj implicitly has an any type, and I set the TypeScript up with to be strict. So it is not okay to have an implicit any. We can make something any anyways, but it doesn't like it. And properties we have not typed either. The accumulator we haven't typed, and the property in here also has an any type. So let's work on fixing those. What? Resize the panel. Here and npm run tsc, so we see the errors again. So up here in my pick function, nothing is typed yet. So I am going to say properties has to be a string array. That much is certain. I have to run it again because it took the the code from before I ran it. Before I changed it, I mean. And waiting. We went do something. we went from 4 errors to 2 errors. So the one with the property being undefined, being untyped, that is gone because we know that properties is an array of strings. And we still have the object untyped, which means that it says here, element implicitly has an any type because expression of type string can't be used to index type object, empty object. So what is in our example, an object is of type, it's an object that has keys of type string and whose values so far are all strings. So this would be our type, I think. npm run tsc. My tests fail, but it's still the test with the 17. Returns an empty object if no array of properties is passed. I'm going to see why that isn't really a problem in the first place. Element implicitly has an any type. Now I get to my TypeScript knowledge again. So here we pass it an object. And let's actually go back to what we had before. We can still iterate over it. Actually, why make life more complicated than it needs to be now? Let's say we go back to mapping over the properties. That's the same, does the same thing. Result. And return result. Just because that's how I still know how to make TypeScript a bit happier. Still not fully on board with everything there, but this should help a tiny bit. It'll still complain in a second with the same with a very similar error message. Yeah, this one is not typed because it doesn't know what type result is, so let's give you the same. You have a key of strings and your values are all strings. Right? Okay, I need to make sure that this is a bit faster next time. Now it doesn't complain anymore, so TypeScript is happy, which isn't good because I am now using the function wrong. I think I have this in my ts config. Yeah, don't exclude those files. I had it set to not run TypeScript on the test files themselves, and if I do something against those types, that didn't show up before. It now should show up because here we are passing, and that's what we're going to jump into VS Code for a second. Code dot argument of type number is not assignable to parameter of type string array. So we told it properties. We expect properties to be an array of strings, and it won't let us pass in a number now. That is the pick test TS. No, I don't need the release notes. Come on. Why are you so slow? Where's my TypeScript at? Oh, I have I tried a Jest plugin earlier. Let's disable that. We have the test running on the terminal. Just disable, thank you, but I will do that in another way. Okay, now the error here shows up. Properties map is not a function. Argument of type number is not assignable to parameter of type string array. So the second parameter of this pick function we expect to be a string array. We can't pass in 17. We can't pass in. Can we pass in undefined? We can't pass in undefined because it's not an optional parameter. If we had said in the function definition that it's optional, this would be fine. It can't be null. It can't be an array of 1, 2, 3, 1, 2, 4. It can't be an array of numbers or it can't have any, the array can't have any numbers in it because I only expect strings. Only if I put all strings in here is it happy. And what's up with you? Returns an empty object. Property is not a function. No, that is not true. Save it. I think the jest is still running here. So my tests pass now, but this test has become unnecessary because I don't need to check for all eventualities that I don't have to check for all the eventualities that these values could be. I don't even need to check for what if age is 17, because my function right now only expects values that are of type string. There is no nesting, there is no, I couldn't do address, street, high street. I couldn't do that because my TypeScript tells me everything has to be a string. It can't be an object, it can't be a boolean, it can't be a number. Of course, not ideal, but the point is that we don't need to test for all kinds of elements of all kinds of types that people could throw at this, because that's a whole category of issues that TypeScript takes care of for us immediately. There's nothing else we need to do. We can focus the tests on what it is that we want the function really to do, instead of covering situations that might never happen and that can be picked up by static type checking. So there are lots of brownie points for TypeScript. Is it ideal that we can only pass in strings here? Of course not. We could now extend this. We could say you can be a string or a number or is it bool or boolean? But I'm not going to do that. This is about the test-driven development. And if I know that in my project it's only ever going to receive strings, why do something else with this? Why cover a scenario that is not going to happen? So I'm not going to do the numbers here. Instead, we are going to move on to another function that we can do, and I want to do something very similar, kind of the opposite of this almost. No, it's not the opposite. It's related to this, at least. So I now want a function. Let's say we have an array of objects. We have an array of locations, for example. And these locations have a city and a country. We're going to do city and country. And we want to get the values of only one of those properties. I'm going to show you what I mean in just a second. So in the source, I'm going to call it pluck TS, and we're also going to write a pluck test.ts. The TypeScript we are going to ignore for a second. And we are going to go to and we're going to start with the pluck test.ts. We're going to do the test first because we're doing this test driven. Describe pluck. And the pluck function, it plucks all values in the objects under the given property. What does that mean? So what I'm picturing here is I want to call the function pluck to equal. We're going to do that in a second. And I want to pass into my pluck, into the call of the function pluck, I want to pass a few objects. Let's say 3 objects. And I have city, Berlin, and country, Germany. And we have city, Paris, and the country is France. And we have the city, Rome, and the country is Italy. And I also pass, of all these, give me the city. iterate, like go through all these objects and only give me the values that the cities have. And I want the result then to be an array of Berlin and Paris and Rome. That's what I want to pluck out of these objects. And my test fails because pluck is not defined. I don't have the pluck anywhere in here because I need to import pluck from pluck. I haven't written the implementation yet, which is fine. We have a failing test. We're in the red, so red stage, red-green-refactor. It still fails because pluck is not a function. In the pluck TS, we need to export default function pluck. And it went from just, it said pluck is undefined to it returns undefined. We expected the result to be Berlin, Paris, and Rome. We received undefined. Cool or not cool? We want, and I'm gonna skip the step where I only have it return the array that's hard-coded to Berlin, Paris, Rome. We know that doesn't really make sense. So instead we're gonna pass this an array and we're gonna pass it a property. And we want to, from all of these objects, get just the given property. And we can return. I'm going to write an implementation that I think is what we want. So return array. We want to map over the array. And for each item, we want to return the property of that. Let's see what that returns, if that is close to what we want. Note that it also still runs the pig tests. And the test is green. This does what we want. We could now cover other types of values. We could now cover what if we want to get only the numbers. And let's do that. It plucks numbers from the objects. Let's say we expect the pluck, pass it an array of objects, and we will want the age from them to equal. So let's say we have people. Nope, sorry, that was yes. Let's say we have name Bob, age 31, and we have, nope, that not the empty object here. We have name Alice, age 47, and I want to get only the ages, so passing the property age in here, and I expect the result to be 31 and 47. Does the function already do what we want it to do? Let's wait for the test to come back, and that passes, so the function does what we want it to. What's missing? We need to run npm run tsc. We need to run tsc again, or we could go into VS Code. Let's actually go into VS Code. Pluck test. I thought I had you disabled. Oh, reload required. Okay, what? Okay, now I got rid of VS Code. Does not what I wanted. Bring it back, please. Where you at? Here you at. So in my pluck test, everything's fine. And here it now complains about this is an implicit any. This is an implicit any, and we know that the property, let's say the property always needs to be a string because the key is a string, and the array is an array of objects that have a shape. How do I do that? So I have key is string, and let's say this has to be a string also, and I want an array of view. Is that fine? That is fine. So an object, many elements that have the shape of there is a key that is a string, and the value is a string also. That is fine. TypeScript is happy with that. And that's the wrong file. We want the pluck test. And now it tells me again, hey, you said this would be a string. It's not a string, it's a number. It's not a doomer at all. So let's say this can be a string or a number. TypeScript seems happy with that, both here and here. And we have a neat little helper function that plucks values out of these objects. Let's look at the tests again. Let's look at the correct tests again. We have a helper function that we can pass a list of objects, and we can pluck either strings or numbers. We could do the same for booleans. I'm not going to do that here. If we want to extend that, we can, of course, but instead let's continue to another test. What could we do? We could do, so this can be a list of helper functions that I use across all of my projects. And let's say I want a, even though it's not technically difficult, but let's say I want a last.test.ts. I want a function. I'm gonna start by writing the test. I'm gonna figure out what I want it to do. Describe last. It returns the last element in an array. That might even be a function on the arrays now, isn't it? Is that a thing now? MDN array last. That might be something that they're adding. Do we have last? Okay, so here they do that still with the bracket, or they're popping it out from the end. That's not always what we want. Okay, so we want to turn this into a helper function, and I don't copy. Okay, neat. Pop out, but there is no last function on here as of now. Good to know. So we can expect, we're going to call last on an array that's 1, 2, 3, 4. And we don't need to pass a second parameter. We can just pass a single array. We want this to be 4. And let's do multiple expects in the same it here. Last of the array true, false, 17, 8. Hello. To be hello. So in JavaScript, there's nothing that tells us these have to be uniform. We can mix and match values in arrays as much as we want. So we can have Boolean values and numbers. We don't need as many in here all at the same time. That's perfectly fine. Let's say let's see if we can have TypeScript accept that though, because it might not be happy with that. I don't know. Source new file. So now it complains that we don't have the last anywhere. Last.ts. We need to import last from last. Last doesn't return anything yet, doesn't export anything yet. Export default function last array, and as I said, we want to return basically this. We want to make this a helper function. That is fine. Let's see if the tests pass. That we can do in the terminal again. So we have 6 total tests across 3 different files, and they're all green. So do we even see that fail? We didn't even see that fail. yet really, but it's fine. We started with the test first. And now this is untyped. It implicitly has an any type. To make TypeScript happy, I could say sure, it can be anything. But then I could even pass the number 17. I could pass a Boolean value. I could pass a string. I really want it to be an array of something. So an array of, let's say, numbers. But then I could only ever get the last element from an array of numbers. And if there's other values in here, it wouldn't be so happy. So I think we can use, for the array, we can write it either like the type and then the square brackets, or we pass it the array and then in the angle brackets the type that we want, because array is an interface that has a generic. You can be an array of numbers. Still doesn't solve this problem. Let's put you top to bottom. So you can be numbers or you can be Boolean. So we now told it it's okay if this is a number or a Boolean. It's not happy with the string yet. Now it's happy with the string and it does the thing. Here it could also contain undefined. It could contain null. It could contain an object. It could contain another array. Another array could be the last element in this top level array. It could even be a function. It could be all sorts of things. And going through those here and adding all possible values it could be seems futile. Like we wouldn't stop writing this type here. So I'm just gonna say where it says the t here, the parameter t, any. An array of anything. As long as it is an array. So we still couldn't go expect last from hello. We couldn't say I want you to give me the O, because TypeScript tells us you have to be an array. You have to be an array of anything, but you have to be an array. So if we call it hello and we split it, we would turn the string into an array and it would be happy. That'd be perfectly fine. But it can't be a non-array. Anything can be in here. So we could even make this a is 6. We could even put objects in here and that'd be perfectly okay. If that is a structure that can happen in our code, then I am okay with having the explicit any there. Because maybe it comes from a backend somewhere, maybe it is a tuple of values that have some meaning, some relation together, like two values that represent different types of things, but they are a logical group. Having an array of any seems reasonable enough. And save the test, make sure that the test still passes. It always runs all tests here. Usually it would only run the tests that changed. When we watch it, might be a misconfiguration on my end, most likely. And what else can we create tests for? I'm looking at some examples that I have here. I think clamping would be nice to see how it works with higher order functions. Clamping. Imagine we have an array of numbers. Let's say we have a readout from a temperature sensor somewhere in our home. And we have a Raspberry Pi running and it receives data, it receives a constant stream from that sensor. But sometimes, because it isn't the best sensor, it goes haywire and it gives us a completely unreasonable value. It goes from like 30 degrees Celsius to 31 degrees Celsius to 30 degrees Celsius to 1000 degrees. that doesn't, it's not suddenly going, well, hopefully it's not suddenly going to be 1,000 degrees in our apartment right before it goes back down to 30. So we could say there is a logical upper bound for the numbers in this. There is a place I would clamp you in. And is that what I want for the clamp? Hello test empty list. What about return type? On what function from the chat? On what function you mean? On the one with the last? Oh right, that is a very good point. Sure, we weren't very exhaustive with the tests here. I can add more cases to this first also before we go to the clamp. That is a very good idea. It returns. What do we want it to return? We want it to return undefined. It returns undefined when passed an empty list. Sure. Expect last from an empty list to be undefined. And let's run the tests in here. Nope. Where are you? Yes. Nope. npm run test watch. So I'm gonna run the tests right here. I'm gonna put that away. I can now define that if I don't pass in, if I pass in an empty list, I get undefined. What did it do? Let's see if let's make the test fail first. Let's do something that it doesn't. Let's have it. I just want to see some red, so I know that what I'm doing is right, because it being green immediately, that threw me off. Okay, expected not undefined, but it received undefined, so that apparently was fine. What was the other suggestion? What about return type? How would we test that? The return type here, because it is an array of any's, would still be an any, right? What else could how else could I confirm that it is the right type? Let's see if those tests still pass. Okay, that's what I wanted. If a function can return undefined, I try to always use any or undefined. Okay, right. So I can be explicit here. Does it? Okay, cool. What is it typed as? Any. Okay, cool. If it can return undefined, we don't want to just say it could be anything. But that is a good suggestion. Thank you very much for that. Undefined. So we know it can be undefined. It doesn't change anything about what it warns us about, but it is more explicit in that it tells us, if we hover over here, what you get from this is an any, or it can potentially be undefined. So we could catch that in situations where we use the last function. Cool. Yes, totally with you on that. I am going to. I think there's a bit of a delay here in the chat, unfortunately. So you wrote it and then took me a while to see it. New file, clamp.test.ts. Yeah, it just makes the user of the function aware that he might have to check. Yes, absolutely. I agree. With the clamp. So with the next, let's do one more, right? What's the time? Oh yeah, easy. Let's keep doing a few. I imagine the scenario is the temperature sensor that returns a bogus value. Describe, and I'm going to call the function clamp because I want to clamp it between the logical upper and lower bound. The temperature in the room couldn't go beyond these values. It clamps all, and this will be numbers only, this function, I assume. It clamps all values between a lower and upper bound. Might make sense to put these in separate tests and not check lower and upper at once. I'm gonna see how long that test, how much that test has to cover. So it clamps all values between the lower and upper bound. Expect. What are the clamp? How do we use that function? How do we use that function? What are the temperature values that we recorded? I am going to go European on you, so it's going to record 21, 8, and I say that's across different hours or days. It's not gonna randomly. It's not gonna it couldn't possibly fluctuate that much quickly. It was 19 on that day, then it was 1000 degrees on that day, and the next day it was 21 degrees again, then it was minus 999, and then it was 0 degrees maybe, that seems realistic enough, and then it was 17 degrees. Okay, sure. So I want to clamp you between the values of what's a reasonable temperature. It could be minus 20. It could be 60 degrees. It's like where I live, those are reasonable temperatures. And then I expect the result to equal, I think with the array, probably could do the 2b. I could say if I get a bogus value, I could throw it out, or I can say you can't be larger than 60, so I'm gonna make you 60. You can't be lower than negative 20, I'm gonna make you negative 20. So I'm not removing the value, but I am bringing it into a realistic range. Could be for temperature, like I'm thinking mostly of sensors here, temperature and speed and humidity. In case of a faulty reading, we don't have clamp, so we need to import clamp from clamp. Clamp doesn't exist, add a new file, clamp.ts. Export default function clamp, and I will change that how we use the function in a bit, because I had something else in mind here. No, you are not an arrow function yet, so we could say you are an array, and let's do a shortcut here, because I know I only expect this to receive numbers, and a lower, which is a number, and an upper, which is also a number. Let's say lower bound and upper bound also. For now, we will return the array as is. Have the test run. I'm not sure. I'm gonna check the configuration why it's running all tests and not just the ones that changed. Something for next time. So we see it does return something, and instead of I'm not getting 60, I'm getting 1000. I'm not getting negative 20. I am getting negative 999. So we will have to, for the array, we will map over each value. Does it make sense to call it array then? Is it easier to call it numbers? Can I call it number then? Numbers. So for each number in the numbers array, I want to return, and just to see what it does, number minus 1. Just so we know what we can anchor this on. I will now get only bogus values. Yeah, because instead of 21, I got 20. Instead of 18, I got 17. That, of course, that is not what we want at all. So I want, what do I want? We have to compare each number to each of these bounds. So if I have a number in my array that I'm walking through, and I have a maximum that it can be, I want to get the lower value out of these two, right? So if I have the value 20 and the maximum is 100, I want the lower value. If I have the value 1000 and the maximum is 60, I want the lower value. So I always want the math.min between the number and the upper bound, right? So that would give me at least one of the cases covered, I assume. Okay, so instead of the 1000, we get the 60. We also want to make sure that we get the maximum of the opposite direction. So if we have 0 and the minimum value it can be is minus 20, I want the larger number. I want the 0. If I have negative 999 and the minimum value is negative 20, then I want the larger number of these two. I still have to compare it to the math.min with the upper bound. So math.max out of whatever we received before. So the lower number between the current number and the upper bound, and then the higher number between this number and the lower bound. Does that make sense? Does that work? That is the beauty of test-driven development, because if I had messed this up now, if I had mixed them up, without the test, that looks fine. That looks absolutely okay to me, because it looks confusing. I want the math.min of the number and the lower bound. Minimum sounds like a lower bound, and then maximum sounds like upper bound. Sounds like upper bound. That is probably okay. Let's just commit it. Let's push it to production, and then you find there is a bug because of course it doesn't work. I don't really have to do much thinking here because the test does the thinking for me. For the input that I have in my test, I expect a certain outcome. This is hilarious because meaning well and pushing this implementation to production, I don't get 21, 18, 19, 60, 21, minus 20, 0, 17. I get 60, 60, 60, 60, 60, 60, 60, 60. I only get 60s. That is not at all what I want, so I know because my test fails, my implementation is wrong. Upper bound and lower bound. If I reverse that, I could still be missing something in my implementation. I might again not have enough tests. There might be another edge case that I want to cover. And let's do the one that was suggested earlier actually. It does nothing with an empty array. Well, does it? It does something actually. But if we expect, nah, that's a bad test description. Let's change the test description in a second. So let's first see, because we have TypeScript, what would happen if I remove the upper and lower bound. It would complain, hey, argument for lower bound was not provided. Okay, lower. And thanks to TypeScript, I don't need to check, is this a number at all? That's something that TypeScript takes care of for me. Had that sentence, I said that sentence before, and also didn't know if it was grammatically correct. An argument for upper bound was not provided. Upper. Now tells me, well, you are not a number. So I have to provide a value here, even if it is a 0. That's another case we could cover, like what happens if both lower and upper bound are the same. in this case, and we see the test fails because I expect all of this, but I get an empty array. Returns an empty array when passed an empty array. And I want to see what happens. I first want to see what happens when I pass in the same lower and upper bound. So let's say this was between 1 and 100. And it turns in an array. Oh, turns an array of all the same number when lower and upper bound are the same, is what I expect it would do. So if I pass it, I don't know, just random numbers, 4, 8, 15, 16, was it 23, 42? Those seem like numbers, and if I now pass it 20 and 20, what's the result? We're gonna have the test tell us now, because implementation is good enough. And the test will tell me, if I tell it I expect an empty array, well, I'm not getting an empty array, most likely, because I am getting 20, 20, 20, 20, 20, 20, 20. And to keep in line with the show, it's an array of all 108s. 108, 108, 108. God, I need to learn my keyboard. 108, 108. While we are here, I want to show you something super neat about how we can write numbers in JavaScript, because we have here 21, 18, 19, 1000, and it becomes difficult to see how many zeros we have in a number. I can just add an underscore, it will still be 1000, but I can separate it and make it more readable, which is very neat. I can do that for 1000, for a million, for all the numbers, even if that's a higher value, of course. And now I neglected to check the test result first. Was up to equal 108. Okay, I forgot a value. It does 108. Here for the clamp function is perfectly fine to say it's all numbers. Everything's a number. It doesn't make sense for the lower upper bound to be anything but a number. It doesn't make sense to clamp strings. So that I am content with. There's one more thing I could do with that though. Let's see, so the tests all pass. Maybe I don't want the function to be called like this. Let's say we... Let's say... Yeah, let's do that. Let's say we want to make sure that this works exactly the same, and I want to do a higher order function is what I want. So I want a const clamp, let's say clamp temperature. I want to have, and now in the test I define how I want the function to be used. Clamp temp will be clamp. Give me what's reasonable values to clamp the temperature at. -20. And what are we going to do? Are we going to boil water? So we're going to say 100. And then I want to call the function like this, clamp temp. And I want to pass it only an array. I don't want to pass it both the array and the lower and upper bound. I want to have a function that I pass just the bounds, and then that returns a function that I can pass an array to, so that I could reuse it like so. 4, 8, 15, 16, just random numbers, 23, 42. And if I clamp the temperature here, I want the output to be the same, 4, 8, 15, 16, 23, 42. But this, of course, isn't what the clamp function does right now. That's not how we implemented it. And it doesn't... It now gets called like so. Instead of... Now we have clamp array, lower and upper bound. I want that to be clamp lower and upper bound, and then call it with the array. I want to have a higher order function so that I can have it return a function that I can reuse in many places. Partially because I'm curious to see how I would type that. I don't think I'd type it very differently, right? It's probably just moving things around. So here I would write it like so. And here I would write it like 108, 108, and move that here. Cool. So everything's going to fail because that is not how the clamp function was implemented at all. So clamp will really, and that looks silly easy. Return. How do I return an anonymous function in here? I know how to return an arrow function, so why not do that instead of having an anonymous function in here? So tests are happy. This is an anonymous inner function, and it's fine if that is an array if that is an arrow function, because I don't need to reference it. I like to have this with a name at least, so I could later say it's now the default export. It doesn't have to be the default export. I could have this, I could turn this into named import, named export, so I could have it be a named import as well. And now I forgot to look at the test results again. I basically took this and I took one of the parameters out, and instead of us having to pass the array of numbers with the lower and upper bound, we only pass the lower and upper bound. We receive a function, and we can then to that function pass the array of numbers. It does the same. Why are you not happy? It doesn't do the same as before. What? Because I clamped the temperature at a different value. I had it clamped to 60 before. 60 was my original upper bound, and now it returned a different value. That makes sense. Cool. Yeah, so now that this is an arrow function anyways, we could make this a bit shorter. Make this an implicit return. So I could remove that and make that, because that is only a return statement as well. Remove that and turn that into an implicit return as well. Doesn't read as nice now though, right? Having everything on one line makes it even harder to read. The test will still pass, but there was no harm in having that be explicit returns. So let's keep it. I'd rather have short lines and unnecessary return statements than have everything be on a single line, because it doesn't help with readability. We can rely on it doing the right thing because the test is still green, but that isn't super helpful if we ever want to go in and make any adjustments. Okay, also higher order function with that is sorted. That's all that we needed to do here. Unless someone has a suggestion for a test that we need to write for it. TypeScript takes care of the majority. I don't have to check what happens if I accidentally pass in a number here, because that can't happen. TypeScript won't let that happen. What could we do? What could we do? Yeah, that, okay, I found a neat one. And we are going to get an intersection. Intersection.test.ts. What's an intersection? So I'm imagining a function that I pass two arrays of the same type. Let's say of the same type. Let's limit this to having them be of the same type. And I want to get the values that appear in both of these arrays. So if I have the array 1, 2, 3, 4, and I have the array 3, 4, 5, 6, where do they overlap? They overlap at 3 and 4. I want to get the values that appear in both arrays. Describe intersection. I know it's going to complain about intersection not existing. From intersection, we need to create that in a second. It returns the intersection between two arrays. Expect, and what do we expect? We expect the and exactly that example that I just had. The intersection between the array, no, not objects, between the arrays 1, 2, 3, 4, and the array 3, 4, 5, 6. And we expect that to equal 3 and 4. Source, new file, intersection dot ts, export default. How do I have the tests running over here as well? Okay, yeah, of course. That is no longer necessary because we moved to VS Code again. So why test? I had the test suite running in multiple places at the same time. That probably didn't hurt too much, but doesn't help either. Export default function intersection. So we have an array and another array. And we want to get the values that only appear in one of them. And we can, I think we can filter, right? We can return, let's say we take the first array and we filter. So filter iterates through all values and then returns all of the items for which the filter function returns true. So if I had item here and I always returned true. Why you, okay, you're not happy about the any, that's fine. It now returned everything that was in the first array because filter returned for each item a truthy value. It doesn't have to be true, it has to be a truthy value. And for one.filter, if I iterate over 1, 2, 3, 4, and for every value I return true when filtering, everything will be in there. That's not exactly what we want. Instead, we want to make sure that, and we have the neat includes in JavaScript now, which was added in ES, I forgot. Could have been 6 even. So if, what do we want? We want to filter every item from the first array that also appears in the second array. So if this item also appears in 2, then we want to keep it, otherwise we want to throw it out. And that one direction is fine. Like if we check every item in 1, and we check does it appear in 2, we don't also have to check every item in 2 does it appear in 1, because the overlap would be the same. The overlap would be the same. So it's fine to check 2.include. Is it include? It includes item. Okay, that test passes. that test passes. So that means it gives me the intersection of these here. And I want to now, though, check that it works with strings as well. It was fine because clamping makes sense to limit to numbers. For getting the intersection between arrays, not necessarily so. It works with string arrays. Expect, give me the intersection of what? I'm not gonna go numbers now. Okay. I'm gonna go animals. Intersection of dog and cat and mouse. And no. And the array that is elephant and mouse. What's the intersection between these two? I expect you to equal an array of mouse. Tests run, and it would probably already, yeah, the tests are all green, so the tests pass. But TypeScript won't be happy about this because everything is random. So do we want to limit that? I think we can limit this, because if we have an array of string, like we didn't do it before, but I think it'd be fine to say now you all have to be of the same type. Like, I don't want to compare a string array and a numbers array, and I don't want the arrays to be mixed. I don't want an array to have dog, cat, 28 and mouse and true and undefined. Undefined would be fine, I think. But I want you all to be of the same type. How we do that is the order of returned values defined. Oh, you mean like if we have an intersection of them here, would we always get them in the same order? With how filter works, yes, but we don't have a test to confirm that. We could have a test to confirm that. So can we be certain that this always returns 3 and 4 in that order? And what happens if they aren't neatly just mixed in here? Oh, I think it would depend. Ah, right. It would depend on the order in the first array. So if I do, let's actually not do, yeah, let's do elephant, mouse, and dog. So in the first array, the dog appears first, then we get the mouse. In the second array, we first have the mouse, then we get the dog. What do we expect? Which one wins? Which order wins? And I am going to go with mouse and dog. For what the function does, it isn't really important, but I think because we filter by what's in the first array, and we could have a test that confirms that is what happens. Because now we see, yeah, mouse doesn't appear first, mouse appears second. So we are going to add a test for that. That is a good idea. It returns the intersection in the order from the order of the values in the first array. Yeah. We are going to keep that same. Let's do just dog and mouse, and let's do mouse and dog here. Then we expect it, because now which one wins? The overlap is 100%. The intersection is they are both the same. But what is the order that I expect? And just as long as we have a test to confirm that, then we can sleep well and know that we have this covered at least, and we won't be surprised by it. Don't think we can do anything about the implementation to make it obvious, other than, well, documenting it and adding a hint to other developers what they can expect. And this can't be, I don't think this can be random. Like, okay, randomness in unit tests would be a silly idea. If we have, and I don't know how to cover that. Let's say we have a function that gives us, and I had that scheduled for today potentially, but I didn't do it because I don't know how to cover that. What if we have a function that takes an array and that gives us a random value? We can't reliably write a test for that, because how would we? If it's completely random, what happens? The test, let's say we have the array dog, cat, and mouse, and we have a random function, and we expect it to randomly give us dog. And maybe it works, and randomly it gives us dog, and the next time we run it, it randomly gives us dog again, and then randomly gives us dog again, and we think, cool, our implementation seems to be correct, because we always get dog. But because it's random, sometime it could be mouse. Most cases it can be dog, but then sometimes it's not dog. We can't cover that case. And it would be silly to rely on it always returning dog when we have no way of because then it wouldn't be random. Same as for the input values. In the test, it doesn't make sense here, but if we go back to clamp, what would happen if we said clamp the temperature, we don't need to abbreviate that, temperature, and temperature. What if we said don't clamp it between -20 and 60, clamp it between, you could use the same seed for tests. Okay. Okay, had not considered that. I will have to explore that idea. Sometimes works for when we do dates, right? We have to make sure that timeouts and sleeps and return dates are always the same. It takes a bit of the randomness out of there. What if we said for the clamp temperature, don't clamp it between -20 and 60, clamp it between two random values? We couldn't possibly write an array of numbers to expect here, because it could give us something completely different. Oh, we have an uncovered case here. What if we accidentally reverse them? Right? Like, not even what if they're the same values? What if the lower bound is larger than the upper bound? What would happen? What would happen then? I want to see what that would do. I want to see it. I don't know what this does. When the lower and upper bound are reversed. Huh. What happens if we go 60 and -20? One case here, one expectation, what one expect is enough. Does it remain unchanged? Let's have the test tell us. I could worry about it now, or I could just have the test tell me what it wants to do. Okay, so it's all lower bound. It's all where do we have that? I don't know what this is. So because the lower bound is 60 now, and let's look at the implementation of the clamp. it looks at the lower bound and it gives us the... Okay, right. That is basically what we did when we messed up the implementation. It first gets the lower value of the number and the lower value, which will always be the lower limit, the lower bound. And then we do the same in the opposite direction and say, give me like whatever this number is and the highest value that it can be. So in the test, I think now the time is playing tricks on me. I need to move my streaming earlier potentially, because this is not the most productive hour to worry about that. So let's just document what it does. It's an unlikely case, hopefully, but I want to document what it is. It sets everything to the lower bound if the lower and upper bound are reversed. So u will be, and how many is it? 1, 2, 3, 4, 5, 6, 7, 8. 60, 60, 60, 60, 60, 60, 60, 60, 60. That is 2, 4, 6, 8. That's 160 too many. Is it good that it does that? Not really. Could we fix it? Sure. If we wanted to. If we wanted to, we could go into our implementation and say, you just get bound 1 and bound 2. And we first figure out which one of you is lower, and we use that one as the lower bound. Or we say, if you use it wrong, well, it's gonna be wrong. Both are fair. Having it in the test, Nick, I'm not sure if this scenario could ever potentially happen here, but now that we see what would happen if it does, we could say, well, this is not the behavior that I want, because that is silly behavior that couldn't possibly be reasonable to expect. Do we want to account for someone potentially using the function differently than we intended? Well, pointing back at TypeScript, this is what they see when they use that function. The first parameter is called lower bound. The second parameter is called upper bound. If they mess it up, they mess it up. And I don't know what names to use for those that are not lower and upper bound that would still make it clear to them what to use them as. So I say we're going to keep the test and we're not going to fix that, because any fix that we would do to that we could attempt to do would just make it worse and would make it less usable. So it's okay that we have an extra test that can run here, and it keeps sure that that behavior won't change, and then we can continue with our data. May you write a comment that it works for cases lower bound less than or equal to upper bound. I would, if I knew how, because I would like to have a, what do you call them? Right, the comments that show up when you hover over those here. Don't worry, you don't have to tell me now. I am about to close this out, but that'd be something that we can explore as well. How can we add more information to this here so that someone knows what they stand for? Is it not doc type? No, that's HTML. Type doc? Like the documentation that shows up here, will do that eventually. I honestly, sorry, but I don't feel up for much more today. So I think even that I will have to, where were we at with the intersection? So here we added the test with the order, which was cool. And then I wanted to type this. Requires one type argument, array. That's maybe something that you could help me with. How can I? So if I want to make sure these are of the same type, I would use the generics, right? But how do I tell it now what I want that to be? Where in here do I define what T can be? So I think what I'm intending to do here is this intersection function. I think function intersection T. That would have been well, potentially, I guess. What I want to have this say is this function receives two arrays called 1 and 2. Could maybe think of better names for it. And the name of this first array, the type of this first array and the type of the second array is the same. So if one is a string array, the other has to be a string array. If one is a number array, the other has to be a number array. And you return arrays of that type. Cool. Does that do it? Oh. That was much... Okay, I want to see if that... I want to see if that now complains in the test. I'm not going to keep this, but just to make sure, just to confirm, if the first is an array of strings and the second is an array of numbers, type number is not assignable to type string. That is 100% what I wanted to do. It only took a few characters. Okay. The T, the generics, I get it why people just use a T or use an S or use a whatever, use a U. Because that doesn't read as nicely. The abbreviations would make this look a bit cryptic to me, but it expresses exactly that. If one is a string array, and we're gonna do the reverse even here, because I think the first one defines what the types are, right? Right, so the second array will always be the one that's in the wrong. If the first one is an array of strings and the second one isn't, well, type number is not assignable to type string. This has to be a string array. If the first one is an array of number and the second one is an array of strings, well, type string is not assignable to type number. So the first array wins and defines what the type is for the rest of this function call, which is neat. We can now, reading from the chat again, and when you use it, if you don't have to put the T after the function name, TypeScript will use the type of the first for matching the type. When you use it, you don't have to put the T after the function name. TypeScript will use the type of the first array. Yes. Okay, cool, exactly. I think that's what I just tried. And that is nice. That is nice. We didn't have to put this limitation on this, to be fair. It could have been perfectly okay to say, if one is an array of strings and one is an array of numbers, and we try to find the intersection, and there is nothing, that is fine. We didn't have to limit it to be of the same type. I just want to see if we could do it. We didn't do that in the other functions either. Well, to be fair, we didn't have that situation yet. But I think it makes sense. I'm probably gonna have to go through all of these now with everything that we learned during this and see if there's a neat way to adjust everything. But I think for now, not sure what happens when you use. Okay, yeah, okay. Let's check that. What happens when we use mixed arrays? I would assume. Okay, so what happens if we put in, if the first array isn't just strings, but it's strings and numbers and booleans and objects and whatever? I would assume that the t always has to be the same t, but I am not sure and I want to see what it does. So if this is 16, oh. Okay, so it doesn't. It doesn't. As long as this, if this is mixed now, what does this tell me? And it learns that the type is string or number. Okay, if I don't have a number here, then TypeScript figures out, okay, this is an array of strings. Has to be strings that we're talking about here. If I have a mixed array, it learns, okay, can be string, can be number. What if I have a true as well, and a null, and an undefined? It learns that t can be string, or number, or boolean, or null, or undefined. And it's sort of like the type starts exploding, because that now applies to both of the arrays and the return value as well. I don't feel like fixing that, honestly. I think that is fair, because the scenario would be we have an array of things and we want to see which of these things appear in an array that has the same kinds of things. So if you only use strings or numbers in first array, you can't use boolean in second array unless you use intersection. So I think if I did this, could I do this manually? Yeah, okay, so if I define I want to use intersection, and the generic type that we use in the definition always is a string, I could limit it myself when I use it, but I didn't limit it from the implementation, so I'd leave it up to the user. Yeah, nah, that's okay though. I think that's okay. Again, where could we have mixed values in the first place? The scenario that the example that I use there always is recipes. You have recipes and you have a bunch of arrays. One is a value and one is a unit. 15 grams, 2 cups. One is a string, one is a number, one is a string. And if I want to see overlap between multiple tuples, that's fine. It could be an artificial limitation that we don't need to put on here, but I'm going to keep it as it is. For the streams, I tend to jump through topics a bit, I found. So I thought I'd continue with the design that we did on Tuesday. I ended up just not feeling like spending much more time in Sketch today, and it will stay a mix for a bit. And I hope you're gonna stick with me. Like, if you have favorite topics, like if you want to see more TypeScript, I try to announce that early enough. Could be design, could be something like today, could be more React and Next. That's something that's definitely on the agenda for relatively soon. I always have to base what I do on what mood strikes me for the day. Until I find the thing that I am most comfortable with and the thing that I find people enjoy and can participate in. I think TypeScript is a contender for that, and I am still trying to pick up. Hi, Cooper. My dog notices that something is happening. Big English laughing. When I found something, I will probably stick with that for a bit. Right now, I'm experimenting with a lot of different topics. Check back in when you see there's something that is of interest. I am again super grateful for the feedback and for the recommendations. Again, learning more about TypeScript with each time that I am doing that. The video will be on YouTube tomorrow, on Twitch for another few days. Thank you for participating. Thank you for watching. I will do another session on Tuesday, same time, 10 p.m. Central European time, 4 p.m. whatever America time zones are. I will talk to you soon. Have a lovely rest of your day. And again, thank you very much. And super great that you checked back in again. I'll talk to everyone soon. Bye bye.